Hello everyone. Welcome back to Learn Smart with Sweta. This is part 2 of our Trigonometrical Identities series from RS Aggarwal Class 10 ICSE Mathematics. In this video, we will solve questions 16 to 24. So let's get started. Let's look at question number 16. Question is sin A into 1 plus tan A plus cos A into 1 plus cot A equals to sec A plus cosec A. LHS, let's solve. So what we will do here, we will write tan A as sin A by cos A and cot A as cos A by sin A, and let's see. Sin A into 1 plus sin A by cos A plus cos A into 1 plus cos A by sin A. Now what? Now let's take the LCM and simplify this, and let's simplify this. So we will write sin A into 1 plus cos A into basically cos A plus sin A upon cos A. And same way here we will do cos A into sin A plus cos A by sin A. So let's write cos A into sin A plus cos A upon sin A. Right? And look at over here, cos A plus sin A here, sin A plus cos A here. So we can take that as common. So we can write cos A plus sin A. And what we have left with here is sin A upon cos A. Let's write that sin A upon cos A plus here what we have left, we have taken this as common, so cos A upon sin A. So here we will write cos A upon sin A, and there will be no brackets actually, so let me remove this bracket. So this is sin A by cos A plus cos A by sin A. So here again we will take LCM. So let's take, so here we will write cos A plus sin A. And if we take LCM, what we will get? Sin A into cos A. Sin A into cos A. And here what we get? We get sin square A plus cos square A. Now again we will do the same thing. We can write sin square A plus cos square A as 1, and let's write that. So this will remain as it is, cos A plus sin A. We will write that cos A plus sin A and 1 upon sin A into cos A. 1 upon sin A into cos A. Now, so cos A upon sin A cos A and plus sin A upon sin A cos A. We can write that? Let's write that. That cos A upon sin A cos A upon sin A cos A and plus sin A upon sin A cos A. So see, we can here cancel cos A and sin A and sin A. We are left with 1 upon sin A. 1 upon sin A is cosec. We will write cosec A plus 1 upon cos A is sec A. And we are getting the RHS, so we can prove it. So basically what we did in this question, we just wrote tan A as sin A by cos A and cot A as cos A by sin A. Take out common, whatever is common. Here I was saying that I saw cos A plus sin A is common, we have taken that as common. Whatever remains, take the LCM and just solve it. Simplify, solve, then you get the answer, right? Let's see the next question, question number 17. So let's look at this question. And we have to prove that 1 by 1 plus tan square A plus 1 by 1 plus cot square A is equal to 1. We will do the same thing which we have done in all the questions. Tan square A we will write sin square A by cot square A, and cot square A we will write cos square A by sin square A. So we will write 1 upon 1 plus sin square A by cos square A plus 1 upon 1 plus cos square A by sin square A. Which means, again, let's simplify this, the denominator. We can write it as 1 upon cos square A plus sin square A upon cos square A. And here we can write 1 upon sin square A plus cos square A by sin square A. Sin square A plus cos square A by sin square A. Now what? Now just reciprocal. So we are simplifying this. We will get cos square A by cos square A plus sin square A. Plus sin square A by sin square A plus cos square A. Now what? Now both are sin square A plus cos square A, here also sin square A plus cos square A. So we will write it as cos square A plus sin square A. Numerator we are writing together because the denominator is same, cos square A plus sin square A. And we know that sin square A plus cos square A is 1. So we are getting 1 upon 1, which means we are getting 1. So we are done with question number 17. Simply, we have written tan square A as sin square A by cos square A and cot square A by cos square A upon sin square A. And this is the easier method to solve. If you write 1 plus tan square A is equal to sec square A and 1 plus cot square A is equal to cosec square A, you will still get it. And this is how also simply by following the same rule that everywhere write, most of the places write tan as sin A by cos A and cot as cos A by sin A, and you are able to solve it very, very easily, right? Let's see the next question, question number 18. Let's look at this question. 1 by 1 plus sin A plus 1 by 1 minus sin A is 2 sec square A. Now, here, only thing that we can do is we can take the LCM. Let's do that. So, LCM will be 1 plus sin A into 1 minus sin A. And in the numerator, what we will get? We will get 1 minus sin A plus 1 plus sin A. And minus sin A and plus sin A will cancel. What we are left with? 1 plus 1, which is 2. So 2 upon 1 plus sin A into 1 minus sin A plus B into A minus B, which is A square minus B square. And 1 minus sin square A is cos square A. So we will write 2 upon cos square A, which means 1 upon cos square A is sec square A. So we can write it as 2 sec square A. And we are done. So what we have done over here, just taken the LCM, sin A and minus sin A plus sin A cancels. 1 plus 1 is 2, you get that. Denominator, you write this as 1 minus sin square A, and which can be written as cos square A, and then you get 2 sec square A. Let's see the next question, question number 19. Let's look at question number 19. In this question, also, we will only simplify, so we will take LCM and try to solve. So let's do that. We will write cos A into 1 plus sin A, and now this will become 1 plus sin A the whole square plus cos square A. Now let's write this as A plus B whole square. So A square plus B square plus 2AB, which is 2 sin A, and plus cos square A upon, so the denominator, let us keep it cos A into 1 plus sin A. Now what? Now see, here we have sin square A plus cos square A. We can write this as 1. So we will get 1 plus 1 and plus 2 sin A. And upon cos A into 1 plus sin A. Now what? This 1 plus 1 we will write it as 2. We will simplify. We will write 2 plus 2 sin A. upon that same thing, cos A plus cos A into 1 plus sin A. And we will take common. So 2 common, then 1 plus sin A upon cos A into 1 plus sin A. Now you can cancel this and you are left with 2 upon cos A, which means 2 sec A. And see, we are done. Let's see the next question, question number 20. So here, we will not write first, we can see that this is cosec A minus 1 into cosec A plus 1. Let's take the LCM and try to solve. So, if we take the LCM, what we will get? Cosec A minus 1 into cosec A plus 1. And here we will get cosec A plus 1, cosec A plus 1 into cosec A. And plus cosec A plus 1 will cancel cosec A minus 1 into cosec A into cosec A. Now let's simplify it. Let's multiply and simplify it. Cosec A into cosec A. Cosec square A plus cosec A plus cosec A into cosec A, cosec square A and minus cosec A upon cosec A minus 1 into cosec A plus 1. So cosec A minus 1 into cosec A plus 1. So you can see over here minus cosec A plus cosec A. You can cancel. And cosec square A plus cosec square A. We can write it as 2 cosec square A. So we will write 2 cosec square A upon, this is what, cosec A minus 1 into cosec A plus 1, which can be written as cosec square A minus 1. So we will write this as cosec square A minus 1. Now what? See, cosec square A minus 1. There is an identity that 1 plus cot square A equals to cosec square A. So, cosec square A minus 1 can be written as cot square A. So, we will write cosec square A minus 1 is equal to cot square A. So, we will use this identity. Here, cosec square A minus 1 we will write at cot square A. So, we will write that 2 cosec square A, 2 cosec square A upon cot square A. So, 2 cosec square A upon cot square A. And now we will write cot square A as cos square A by sin square A. So we will write 2 cosec square A by cos square A upon sin square A, and let's write sin square A over here. Right? Now we have to get to sec square A. So sin and cosec, they are reciprocal of each other. So cosec square A into sin square A, because sin square A is 1 by cosec square. So this we can simply cancel, and this will become, we are left with 2 upon cos square A, which means we are getting 2 sec square A. So here one important identity that we are using is 1 plus cot square A is cosec square A. So cosec square A minus 1 can be written as cot square A. So here we were getting cosec square A minus 1, we write that as cot square A, and this is the identity that we used. And we wrote this as cot square A, and then again we wrote this cot square A as cos square A upon sin square A. We cancel and we are getting 2 sec square A. So this is how we can solve this question number 20. Let's see the next question, question number 21. Let's look at question number 21. We have cot A, cosec A, tan A, sec A. We will write everything simply. Cot A as cos by sin, cosec as 1 by sin, tan as sin by cos, and sec as 1 by cos. And simplify it. Let's do it. So we will write 1 plus cos A by sin A minus 1 by sin A into 1 plus sin A by cos A plus 1 by cos A. Now what? Now we will simplify by taking out LCM. So what we get? So we'll take LCM, we'll get sin A. So this will become sin A plus cos A minus 1. And here what? Here also we'll take LCM. So we will get cos A plus sin A plus 1. So the numerator is A minus B into A plus B. We can write this as A square minus B square and upon sin A into cos A. So sin A plus cos A whole square, we'll write it as sin square A plus cos square A and plus 2 sin A cos A and this minus 1 upon sin A into cos A. Now see nicely, here we have sin square A plus cos square A, which will give us 1, and this 1 and minus 1 will cancel. So I am cancelling this, this and this. So what we are left with 2 sin A cos A by sin A cos A. So 2 sin A cos A by sin A cos A. And we get 2. And we are done. Let's see the next question. So what do we do over here? Sin A plus cos A whole square. Let's do here A plus B whole square and here also A plus B the whole square. And let's see what we get. So we will get sin square A plus cosec square A plus 2 sin A cosec A. 2 sin A cosec A. And same thing let's do over here. Cos square A, we are doing A plus B the whole square. So cos square A plus sec square A plus 2 cos A sec A. Now what? See, sin A and cosec A, they are reciprocal because cosec is 1 by sin. So we can cancel this. Here also sec is reciprocal of cos. We can write sec as 1 upon cos. So this also cancels. What we are left with is sin square A plus cosec square A plus 2 is 4 and plus cos square A plus sec square A. Now what? Now see, we can write this sin square A plus cos square A as 1. So we can write 4 plus 1, that is 5. So 5 plus cosec square A plus sec square A. Now what? Now we know that 1 plus tan square A is sec square A and 1 plus cot square A is cosec square A. So we will write 5 plus, for cosec square A we will write 1 plus cot square A. 1 plus cot square A. And for sec square A we will write 1 plus tan square A. So 5 plus 1 6, 6 plus 1 7. So 7 plus cot square A plus tan square A. And we are done. So what we can do over here? Let's take the LCM and try to solve it. So denominator we have cos A plus sin A into cos A minus sin A. Cos A plus sin A into cos A minus sin A. After that what? So here we can write this as cos cube A plus sin cube A into cos A minus sin A. plus what? Plus cos cube A minus sin cube A into cos A plus sin A. So what we have done, we have simply taken LCM and after that we are solving. Now what should we do? Let's multiply. So we will get cos raised to the power 4A plus sin cube A cos A minus cos cube A sin A and minus sin raised to the power 4A. Right? And denominator what we can write? Same thing, cos A plus sin A into cos A minus sin A. So, and this part is also there. So this part also same way we will write cos raised to the power 4A plus cos raised to the power 4A minus sin cube A cos A and plus cos cube A sin A and minus sin raised to the power 4A. So let's see that if anything gets cancelled. So sin cube A cos A and sin cube A cos A plus this is minus and this is plus. We can cancel this. What else? Minus cos cube A sin A and plus cos cube A sin A we can cancel. So we are left with cos raised to the power 4A minus sin raised to the power 4A plus cos raised to the power 4A and minus sin raised to the power 4A, which means we can write 2 cos raised to the power 4A plus 2 actually minus minus 2 sin raised to the power 4A and upon cos A plus sin A into cos A minus sin A. What can we do after this? So see, we can take 2 common and we can write 2 cos raised to the power 4A minus sin raised to the power 4A upon cos A plus sin A plus sin A into cos A minus sin A. Now what? So this one and this one, let's try to write in the form of A square minus B square. So not much space here, I am trying to do it over here. So we will write this as 2 and cos square A whole square. Cos square A the whole square minus sin square A the whole square upon cos A plus sin A into cos A minus sin A. Now what? So this is A square minus B square. Like let's write it as A plus B into A minus B. So cos square A minus sin square A into cos square A plus sin square A. Upon cos A plus sin A into cos A minus sin A. And And this we can write actually as cos square A minus sin square A, because cos A plus sin A into cos A minus sin A is cos square A minus sin square A. So let's write cos square A minus sin square A. So this will cancel. So what we are left with is cos square A plus sin square A, and which is equal to 1. And this question, so see, this is 2 cos square A, and here we had missed the 2, so we will write over here 2. So 2 cos square A minus sin this, and this cancels, so we are left with 2. So we will get 2 into cos square A plus sin square A. So we are getting it as 2. So this is how you can solve it. So it looks lengthy, but you have to keep patience and keep doing it properly with full focus, and you will get it. Right? Let's see the next question. Question number 24. Let's look at question number 24. So we will write tan A as sin A by cos A. Sin A by cos A upon 1 minus cos A by sin A. And same thing we will do over here, cos A by sin A upon 1 minus sin A by cos A. Now what? Now let's simplify it. So what we get here is numerator we will write as it is. So we will write sin A by cos A upon sin A minus cos A by sin A. And plus, same way numerator we will keep as it is, cos A by sin A upon cos A minus sin A by cos A. Now what? So now just let's simplify this and let's see what we get. So we can write this as sin A by cos A into sin A. So it will become sin square A. We are only simplifying. And we get sin square A by cos A into sin A minus cos A. Cos A into sin A minus cos A. And next what? Same way here we will simplify. So this will become cos square A upon sin A into cos A minus sin A. So let's write that plus cos square A upon sin A into cos A minus sin A. Now, we will take LCM, but if you look nicely, you will see that here we have sin A minus cos A, and here we have cos A minus sin A, and we want to take LCM. So, we want this also to be sin A minus cos A. The rule is that we change this sign and this becomes sin A minus cos A, and we can write it like this: sin square A by cos A into sin A minus cos A and minus cos square A by sin A into, it becomes sin A minus cos A now. Okay, now what? Now LCM, cos A into sin A minus cos A, we get sin cube A. Sin cube A, and minus, same way here we get cos cube A, and upon we will write that same thing, cos A into sin A minus cos A. Now what? So now this is in the A cube minus B cube. We will use the identity A cube minus B cube is A minus B into A square plus AB plus B square. So the identity we are using, A cube minus B cube, is equal to A minus B into A square plus AB plus B square. This identity we are using, and let's write this. So A minus B we will write, which is sin A minus cos A we will write. Sin A minus cos A. A minus B, then A square, so sin square A. Plus AB. AB is sin A into cos A. And plus B square. B square is cos square A. And denominator will be same, cos A into sin A minus cos A. Cos A into sin A into sin A minus cos A. So, see, this we can cancel. Then what? Then we have sin square A plus cos square A, which is actually 1. So 1 plus sin A into cos A we have, and denominator we have cos A into sin A. So we can write this as 1 plus sin A into cos A, sin A into cos A upon cos A into sin A. So how can this be written? We can write this as 1 upon cos A into sin A, 1 upon cos A into sin A plus sin A cos A upon cos A sin A. Sin A cos A upon cos A sin A. So sin A, this will cancel, so 1 will be, and here 1 by cos A is sec A and 1 by sin A is cosec A. So we can write that as sec A cosec A. This part we can write as sec A cosec A and plus this is 1. So this is what we had to prove RHS and we are done. So this is how, it's again a lengthy one. Only thing that you have to remember is that keep solving with patience and then use the right identity. Like here we got it in the form of A cube minus B cube. Use the identity and you can easily solve it. So it looks lengthy but easy, it is not difficult. You just have to keep solving it and you will get the answer for sure. That brings us to the end of questions 16 to 24. I hope these solutions helped you understand the different approaches used to prove trigonometric identities. If you found this video helpful, please like, share and subscribe to Learn Smart with Sweta. Thank you for watching and I will see you in the next video.